So we've got a rectangle that has two sides, two opposite sides that are increasing. The other two sides are decreasing, and they're decreasing just so perfectly that the area does not change. And they ask some questions about how the perimeter is changing when these different lengths are going on, and then they ask another question at the end. We'll worry about A and B first. So, first thing I'm going to do, draw a picture. It's like the first thing we do with all related rates problems. So I'm going to call this x and this x. We're going to let that be the side that's increasing. So I'm going to say, do I want to use x prime or dx dt? For now, I'm going to use dx dt, but I'm going to change that dx dt equals a positive 2. This is y, and this is y, and that's going to be decreasing all the time. So I should get y values that are negative, because when they tell me it's being shortened, and to keep that area constant, it should make sense that it's going down if the other ones are going up. Anyway, so I'm going to do some scratch work to get a couple of different equations, and then we're going to work with the 5 and the 10 centimeters. So first off, they talk about the area is constant, right? So I know that the area of this thing is x times y, and I know that the area is constant, so 50 is equal to x times y. Now, if I derive that with respect to t, so if I derive that with respect to t, I get that the derivative of the 50 is nothing, and then that's equal to, I have to do product rule, I get x prime y plus y prime x. And this is one where I am going to write it as x primes and y primes instead of dx dt's and dy dt's, just because I think it's easier in this case, as long as I know that that's prime with respect to t. So I know that dx dt is always going to be 2, so I can replace this x prime with 2. So I get 0 equals y plus, or sorry, 2y, that should be 2y plus y prime x. Now that's an equation that we're going to use a bunch. So the next thing is they ask about what is the rate of change of the perimeter. So I know I'm going to have a dp dt somewhere. So I get perimeter is 2x plus 2y. That would be all the way around. And then if I derive that with respect to t, I get dp dt equals 2x prime plus 2y prime. So I'm going to use these two equations right here. And I might get, let's see, I don't think I really need any of that other stuff, so I'm going to get rid of that and save myself some space for the other stuff. So I moved those guys over, and I left this equation 50 equals xy, because I think we're going to use that quite a bit as well. All right, so the first question, A, asks what's dp dt when the length of an increasing side is 5. So that tells me they're looking for dp dt equals what? And they tell me that x is equal to 5. So if I look at this equation right here, that tells me dp dt, but I need primes, right? So I need what is x prime, what is y prime. Actually, I think that this guy's always going to be 2, because x prime is always going to be 2. So I'm actually going to go in there, and I get 2 times 2, so that gives me 4. So I'm going to go in and change that. So what I need to do now is just find find y prime, because once I know what y prime is, then I can find dp dt. So that's what this equation here is going to help me do. It has a y prime in it, it has an x in it, and it has a y in it here. Remember, 50 is the same as x times y. So think about it. I got an area of 50. X is 5. What's this have to be? Well, y has to be 10. I get that by dividing 50 by 5. And now I can use this equation right here to, actually, I can use that equation. I know 0 equals 2 times y is 10, so that's, all right, 2 times 10, plus y prime times 5. If I multiply and move that over, I get a minus 20 equals 5y prime. Divide by 5, I get y prime equals minus 4. So now I can plug that into this thing, right? Because I want to know what is dp dt. So dp dt is going to be 4 plus 2 times negative 4. That's my y prime value. And that gives me equal to 4 minus 8, which is minus 4. So that's my answer for B. At what rate is the perimeter increasing? So it's minus 4, and I should include units. So centimeters per second, it's going to match with that. So I'm not going to do the work on this video for part B. It's basically exactly the same as the work we just did for A. Why don't you go ahead and do it out, see if you can do it. Hit pause first. And you should get 2 centimeters per second for part B. Hopefully that worked out. If it didn't, make sure you just did the same steps all the way through here, and you should be able to find your error somewhere if that didn't work out to be 2 centimeters. Alright, so part C. What are the dimensions? What are the dimensions when the perimeter ceases to decrease? So, remember, we got a negative 4 for the dp dt here, and we got a 4 or a 2 for the dp dt here. So what's the transition between when it goes from negative to being positive, that dp dt? So I know that's going to happen when this thing is equal to 0, right? Because when it goes from negative to positive, it's going to change through 0. So I'm going to take dp dt and set it equal to 0, and I get 0 equals 4 plus 2y prime. Move the 4 over, divide by 2. Actually, negative 4 equals 2y prime. Divide by 2, I get y prime equals negative 2. So that kind of makes sense, in all honesty. When this is increasing at 2 centimeters per second constantly, the perimeter is going to transition from being increasing to decreasing when this is negative 2, right? So when it's kind of like squared out in terms of the rates. All right, so now I'm going to combine that with this line right here. I know y prime is negative 2, so I can plug that into here. So I get 0 equals 2y. Negative 2 goes in for y prime, so minus 2x. If I move the x over, I get 2x equals 2y. Divide by 2, and I get x equals y. So know that x and y are going to be the same thing. Boom, I know that's a square, right? So my last step is to pull in this thing right here. I know x and y are the same thing, right? So there I have 50 equals x times y. And you could go like, all right, well, I know x and y are the same thing. I know it's a square. I know the area is 50. So what do I need those lengths to be? You could go through that process if you want. But I'm going to do it with the equation. So I get 50 equals, well, x and y are the same thing. So I could just replace the y with an x. So I get 50 equals x squared, which tells me x is root 50. Which gives me 5 root 2, which you should be able to do that, split up to 25s. And then that's what y is as well. So it says, what are the dimensions when the perimeter ceases to decrease? Well, x and y are 5 root 2. So it's a square at that spot, which should kind of make sense a little bit.